So on this slide, we want to talk about union of sets and intersection of sets. So union of set A and B. So there are two sets A and B, and we want to define their union. So you denote the union as A union B. So this is the set of all elements So this is the set of all elements which are either in A or B. So these elements are either in A or B. What about intersection? Intersection of set A and B. So now we want to talk about intersection of two sets A and B. So this is denoted by A intersection B. So that is an inverted cap. This is the set of all elements which are both in A and B. So this is the set of all elements which are both in A and B. So let us write down the distinction. So here we have either or in union, and in intersection we have both and. So in union you could lie in either set. In intersection you have to lie in both the sets. So this will be more clear if we draw it pictorially or represent it as a Venn diagram. So first I am drawing a rectangle which represents the universal set. Then we have two sets in it, set A and set B. So their union I will now shade. So A union B is represented by this shaded portion. Now let us do the same thing with A intersection B. First I draw a rectangle which is the universal set, and then I have two sets in it, A and B. So their intersection I will now draw. So this is the intersection. So this is the elements which lie both in A and B. So let us now write some examples. So the first example is you are taking 1, 2 union with AB. So you get 1, 2, A and B. Now we take the same example for intersection. So notice that 1, 2, A and B have no element common. So we get a null set. And this is precisely the definition of disjoint sets. So the set 1, 2 and set A, B are disjoint sets because they do not have any common member. Second, consider this set 1, 2 union with colors red, blue and green. So we will get 1, 2 red, blue, green. Yeah. Similarly, this is similar to first case. So similarly, we want to talk about intersection. Since these two sets are disjoint, we will get a null set as the intersection. So let us write this down. So 1, 2 intersection with red, blue and green, we get the null set. Again, because these two sets are disjoint. And that is what the definition of disjoint set is. Two sets are disjoint, the intersection gives you null set. Now example 3, you take ABC union with BCD. So since set is a collection of distinct elements and B and C is repeating, we just write ABCD. So intersection here now, ABC intersect with BCD, you see you have B and C as common. So one last example. So you take a set and you take union with itself. Since set is a collection of distinct elements, we again get the same set A, B, C. So the union essentially has two A's, two B's and two C's, but since you write on a distinct elements, you are writing ABC. Similarly with intersection. So yeah, both the sets now coincide. Now let us talk about some properties of union. So the first property is, it does not matter how you perform the union, in which order you perform the union. So you can do A union B or B union A, it does not matter. So you can see, for example, for all the examples above 1, 2, 3, 4. So it does not matter how you perform the union. Similarly for intersection, it does not matter how you perform the intersection. So you can see that in the examples listed 1, 2, 3, 4. So this property is called commutativity. Second is, the commutativity means A union B is equal to B union A. So you are changing the two sets, it does not matter. So again we are just carrying and extending the property one further. So yeah, so it does not matter in which order you perform the union operations. So again we are doing, whether you do B union C or A intersection B for, whether you do union first or union later, it does not matter. So 3 is, if you take A and add empty set to it, you get the entire space A, should be A, not the null set. So A union the null set should be the entire space A. A intersection the null set should be null set. A union A will give you A. A intersection A will give you A again. So property number 3 in the union is not correct. I will correct it later. 5 is, you take universal set, you take its union with A, you get universal set. Here you take the universal set, you take its union with intersection with A, you just get A. So now I will correct the error which I made. So this is A union the null set is the entire set A, because in A you add nothing, so you still get A.